This video illustrates how a circuit breaker opens one of the three phases in an in-phase current. In the top panel, the circuit breaker is shown attached to transmission lines. For simplicity, other equipment at the substation isn't shown. In the diagram at bottom left, the alternating voltage in the transmission lines and across the circuit breaker is shown by the green curve. The duration of one wave is 20 milliseconds, and the frequency is 50 Hz. The circuit breaker features a fixed contact on the supply side, and on the load side, a moving contact. To make fast movements in the diagrams easy to see, frequency has been slowed right down to about 1/3 of a hertz. When the contacts are closed, they carry the same voltage. This is illustrated by the pulsing green color, whose timing and intensity correspond with the moving voltage curve at bottom left. The alternating current is shown by the blue curve. The power factor is close to 1, and the current's in phase with the voltage. Current flow in both directions in the circuit breaker is shown by the white lines moving up and down. Interruption of the circuit will first be shown with pauses at key points, and then repeated without the pauses. When the contacts first move apart, the gap's small. The voltage difference between the two contacts exceeds the dielectric strength of the insulating medium. An arc forms, which ionizes the gap, allowing current to continue to flow. Voltage drops to a low transitory value, barely enough to sustain the arc. The instant at which the arc has its lowest heat content, and is therefore easiest to extinguish, is at the natural current zero. At this point, the arc is quenched, and the current ceases to flow. Here's the current interruption again, without the pauses. After the circuit's broken, the voltage of the supply side contact returns to the supply voltage.